This lecture covers the introduction to the idea of probability and the normal curve. This lecture corresponds with sections 5.4 of the textbook, as well as 5.5 and 5.6. And these portions of the textbook are critical to understanding how we use this normal curve to find specific areas underneath the distribution. So first, let's just talk about what this curve tells us. This is the normal curve here, and we have the mean at 0. Characteristics of the normal curve is that it's bell-shaped, unimodal, and asymptotic, which means that this little tail here never actually gets to the axis. It keeps extending out into quite a long period of time. And what we want to understand with probability and the normal curve is that each kind of intersection or each area underneath this curve is associated with a very specific probability. And we need to be able to learn how to use the z-tables that are in the back of the book in table C to define these probabilities. So I know that a score at the mean is associated with a 50% probability, meaning that 50% of the distribution is below the mean and 50% of the distribution is above the mean. But I want to be able to use what I know about standard deviation, which is 1 standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean, etc., to discuss where specific observations lie in reference to probability. Now, just to clarify the idea of standard deviation a little bit, we know that the mean is the exact center of the distribution, and standard deviations refer to points to the left and right of that distribution. So a standard normal curve has a mean of 0, for example, and a standard deviation of 1, meaning that 1 standard deviation above the mean is a value of 1, 1 standard deviation below the mean is a value of -1. Likewise, 2 standard deviations above the mean is a value of 2, and 2 standard deviations below the mean is a value of -2. Now, these are z-scores, okay? Standard deviations of the normal distribution refer to z-scores. So a z-score of -1 corresponds to a value of x that's 1 standard deviation below the mean. Likewise, a z-score of 2 corresponds to an x value that's 2 standard deviations above its mean. Now, Appendix C in Table A in the back of the book shows areas under the curve that correspond to the percent of this normal curve. It shows 2 columns. It shows the percent of the distribution that's between the mean and various standard deviation distances from the mean. And in the book, in your index, the idea of standard deviation is expressed by lowercase sigma. Okay? So this will correspond to how you are interpreting those z-tables. So we have a value that tells us the area between the mean and various standard deviations expressed in sigma, okay? Distances from the mean, and it tells you the point at or beyond various standard deviations from the mean. And so the way that this looks in the table itself, okay? If I want to know, for example, here is my score. Okay? As I've told you before, these scores represent various degrees of standard deviations away from the mean. To get here, this one between the mean and standard deviations, okay? This is going to give you the area here. Okay? So it's going to give you the area of the curve between the mean and the standard deviation. If I do this same drawing down here to illustrate what I'm looking for with the areas beyond, okay, if here I'm looking at or beyond various levels of standard deviations, now I'm going to be looking for this area. Okay? Now, in terms of lecture, the lecture resource, this is the extent of what I can do for you. But there is there are lots of examples in the textbook about finding areas underneath the curve using the tables, and you're going to need to look at those carefully.